What's up, everybody? This is Daddy Mathematics here with another example to explore. And today, guys, I want to go over example 9 and example 10 of problems, of word problems that deal with compound interest, right? Word problems, or real scenarios, rather, that deal with compound interest, right? And in example 9, which is this scenario, this is going to be an example of compound interest being bad debt, which is money spent, right? Or extra money that's spent on a principal that's being paid off. And in example 10, this is going to be an example of compound interest being good equity, which is money gained, right? Or value gained over time due to an investment or whatever the case may be, guys. So remember, guys, when dealing with compound interest, you always want to be on the good equity side. You don't want to be on the bad debt side, because in this particular problem, for example, if you have a maxed out credit card, right, and you paying it off, that credit card is also charging you interest. So for example, if your credit card, if you owe $500, but it takes time for you to pay it back, you might end up paying $750, right? Or you might end up paying close to $1,000 due to the interest that is being added because it takes a while for you to pay off the total balance. So that's the game, guys, when you finance something or somebody loan you something and then they're charging you extra, which is the interest, okay? So let's go over this example, example 9, and I'm gonna go over example 10. And remember, guys, example 9 is an example of compound interest being in the form of bad debt because you owe something and then the lender is charging you interest on top of what you owe, okay? So in this particular example, let me go ahead and start reading. It says you have a maxed out credit card that has a current balance of $8,500, right? The credit card company charges 23% interest compounded monthly, right? So every month, as you paying it off, right? You making those minimum payments or whatever payments, but it's not completely paid off, they're gonna also add an extra 23% of whatever the balance is, okay? If you plan to pay your credit card off in 12 months, which is 1 year, then how much debt will you pay in total? How much debt will we pay in total, okay? So for sure, guys, I can assure you in this particular example, we're gonna end up paying more than $8,500 because we're paying off this debt over amount of time, and then over that amount of time, we're getting charged with extra, which is the interest, okay? So I'm gonna show you how this is bad debt, guys. You don't never wanna be in these type of situations, okay? Trust me, I've been in these type of situations, so I know firsthand, all right? So the principal, guys, is the credit card debt balance, which is the start amount in this particular case. So I'm gonna put $8,500, which is that, okay? The interest rate is, which is the extra that I'm gonna pay on top of the principal, is 23%, right? It's 23%, and 23% is 0.23 as a decimal, 0.23. 0.23 as a decimal, okay? Cool. It said that, yes, I'm gonna be paying off this card within a year, but the interest is gonna be compounded monthly. So that means that the interest is gonna hit my credit card account 12 times in a year, because it's compounded monthly, okay? So that's a lot of extra value or a lot of extra debt that has to be paid off that you really don't have, but due to the interest you do have, okay? And then the time, which has to be in a number of years, it says 12 months, but we do know that 12 months equals 1 year, okay? We do know that 12 months equals 1 year, okay? But we're not gonna operate in months, we're gonna operate in years, okay? So, and then once again, guys, the question is asking, how much debt will you pay in total? So we have all the important parts, so we can plug into the formula. And remember, guys, the formula to find the final amount when interest is being compounded on top of a principal is A, which is the final amount, equals the principal, which is the start amount, right? Times parentheses 1 plus the interest rate divided by the number of times it's compounded, parentheses closed, to the power of the number of times it's compounded times t years, okay? So let's go ahead and do that, guys. Let's go ahead and do that. So I'm gonna go ahead and start right here. So I got A equals P in this particular case, guys, which is the principal, is the credit card balance of $8,500, the maxed out balance, right? Times parentheses 1. So it's going to be 1 plus the interest rate, which is 0.23, which is 23%. .23 divided by the number of times it's being compounded, which is 12 times in a month. 12 times in a year, my bad. 12 times in a year. I'm gonna make that be blue, but I'm talking about this. 12 times in a year, parentheses close, to the power of n, which is 12 times in a year, compounded, times 1 year. T is 1, 12 months is 1 year times 1 year, right? So now, guys, all we have to do, guys, is simplify within the parentheses, simplify the exponent, and then actually solve this problem by just plugging in the numbers into the calculator, okay? So let's go ahead and start, guys. I do want to simplify this part right here first, which is the 0.23 divided by 12. So I'm gonna put that in the calculator. 0.23 divided by 12 equals 0.0191, right? 0.0191, let me go ahead and put that. 0.0191, okay? Roughly around that. Once again, it's a longer decimal, but I'm just gonna stop there. And then we know that 1 plus 0.0191 equals 1.0191, right? So I'm gonna rewrite that inside. And then also, guys, I'm gonna also simplify the exponent, which is 12 times 1, which is still 12. Okay, so I'm gonna rewrite everything. So now I have 8,500 times 1 point, remember 1 plus this equals 1.0191, okay? We can stop right there, to the 12th power, to the power of 12, okay? So now, guys, all I have to do is just plug in this into the calculator the way I see it, right? So I'm gonna do 8,500 times parentheses, outside parentheses, inside parentheses, 1.0191, outside parentheses, inside parentheses close, to the power of 12, outside parentheses close, and that will be the final amount. The final amount is $10,666.46, give or take, right? Of course, this is approximate. So you're going to spend somewhere around $10,666 just to pay off $8,500. So that's actually an extra about $1,600 that you're paying extra due to the interest, guys. So once again, if I subtracted 8,500 from here, let me do that. So I'm just going to subtract it from $10,666. I ain't gonna worry about the cents, right? Minus $8,500, right? Oh, that's actually roughly, I want to make sure I'm right. Actually, guys, that's actually more than $1,500. That's actually more than $2,000 extra that you're paying. The extra that you're going to be paying is $2,166. So you paid an extra. I have to put this, guys. So due to the interest, right? You paid an extra debt of $2,166, somewhere around that, due to the interest rate of 23%, right? So once again, guys, you do not want to be in these situations, guys. You don't want to be in these situations because once again, If you take a year to pay something off and something is being hit with interest monthly or quarterly or whatever, you're going to end up paying not just a few dollars more, a couple of $100 more, but it might be a couple of $1,000 more, right? And of course, guys, the numbers will be bigger if the principal was a bigger number. The amount that you owe will also be bigger, right? Will be larger. So this is an example, guys, of interest or compound interest being bad debt. Now we're going to switch on this side, guys, and we're going to talk about it being good equity, right? In this particular situation, guys, you was already owing the credit card, right? So the game is, oh, since you owe us, we're going to charge you more, right? If somebody owe me, but it's going to take them a while for them to pay me off, I'm going to charge interest. So over time, I'm going to even have more than what they get given me, because just them giving me the principal, right, over time might not be the actual value that I need. I might need more, right? So that's the reason why you get charged with interest when you have debt. Now, here's when you have good equity, right? This is when you invest into something or you open up a savings account and then it builds off interest, what gains your value or grows your value. So we're going to go over it right here. And this is where you gain money, not lose money, okay? So in this particular situation, guys, it says Miles Cunningham decided to invest $3,000 into a stock market portfolio, which guarantees an 8% return compounded quarterly, okay? How much will his stock portfolio be worth after 5 years of accruing interest, okay? So basically, guys, in this particular situation, my partner, right, Miles Cunningham, right, he invested, which is the principal, $3,000 initially, right? He said, you know what, I'm looking at the stock market. People are making good value or gaining interest and equity off the stock market. Why not me, right? And he found a portfolio to where if he invests in that portfolio, he's guaranteed an 8% return on his investment, right? He's guaranteed an 8% return on his investment, okay? And 8% is 0.08 as a decimal, okay? And then, guys, this extra equity, right, will be compounded quarterly. That means 4 times in a year, which is every season, right? So quarterly is 4x, right? 4 times in a year, right? And then how many years he's going to do this, guys, is 5 years, right? So over the next 5 years, guys, he's going to let his balance accrue interest, which adds value to his portfolio, okay? So let's go ahead and do that, guys. I'm going to do the same thing. I have A equals the principal. The principal is $3,000 times parentheses 1 plus the interest rate, which is 0.08 or 8%, right? 0.08 over the number of times it's compounded, which is n, this is 4, so over 4. Parentheses close, to the power of how many times it's compounded, which is 4, times how many years, which is 5. So far, guys, this is how everything should look within the formula. And all we have to do, guys, is just simplify within the parentheses, simplify the exponent, and then just solve going through with a calculator, okay? That's it. So let me go ahead and simplify within the parentheses. I have 0.08 divided by 4, which is right here. That equals 0.02, right? And I'm just gonna add this to 1, okay? And then on the outside, guys, the exponent of 4 times the exponent of 5 equals 20. So this whole thing will have a power of 20, okay? So now I'm gonna rewrite it one more time. Remember, A means final amount. So we have 3,000 times parentheses 1.02 to the 20th power. Just like that, guys. Just like that. So I'm going to plug it in. So 3,000 times parentheses 1.02 to the exponent of 20. And the final amount that he's going to have within his account after 5 years will be $4,457.84, give or take. Once again, guys, these are just approximate numbers. The numbers can give or take a few dollars lower, a few dollars higher, right? But around this, guys, approximately, his portfolio will be worth $4,457, right? $4,457. So I'm just going to subtract 4,457 from 3,000 so you can see how much interest has risen the value of the account, okay? So let me do that. So I have 4,457 minus 3,000, which is 1,457, guys. So his account, due to the interest, right? That's equity, not debt. His account grew an additional $1,457 due to the interest. So $1,457. That's how much his account grew. Right? I'm gonna write grew. So his account grew $1,457 just from the interest that was added to the account as it was being compounded quarterly, which is 4 times in a year and over 5 years, right? So this is the difference between interest being bad debt when you are paying off something that you owe versus it being good equity when you have something that you already own, right? And it builds equity on itself, or value on itself, guys. So once again, guys, these are great examples, real life examples of the importance of compound interest, guys. So thank y'all so much, guys, for the opportunity to allow me to teach y'all this particular stuff, because I'm actually teaching myself, guys. This is actual real life scenarios that I'm applying to my life to make my budget and my situation and my finances better, guys. So this is a great learning situation even for me as a teacher. So thank y'all so much, guys, for the opportunity. I'll talk to you next time.